Our next section says to determine the number of solutions for each system of equations. Now, we've done this in class predominantly with all of our systems being in standard form. So let's look at x plus y equals 7. Now remember, any equation that will give us that exact same line is simply going to be a multiple of this first equation. So if I multiply this by 2, we end up with 2x plus 2y equals 14. And by multiple, I mean we can look at the x's and ask ourselves, what could I multiply x by to get 2x? Well, that would be 2. What could I multiply y by to get 2y? That would also be 2. What could I multiply 7 by to get 14? Again, that would also be 2. So since we're multiplying the equation by the same multiple for each term, we're going to end up with the same equation of the line. Now, let's go back to our x plus y equals 7 equation and assume for just a second that we multiply x by 2, y by 2, but then we have our constant out here that's 3. Now, remember when we put this in y equals form, I subtract 2x from both sides, so that will give me 3 minus 2x, and then I divide by 2. What I really want us to see here is that the slope is negative 2 over 2, which is 1. Sorry, negative 1. Now, if I do the same thing for the first equation, I put it in y equals form, that means I'm going to be subtracting x from both sides, and it also would have a negative 1 slope. So the slope would be the same, but the y-intercepts would not. Since they would have different y-intercepts, we're going to end up with parallel lines that have absolutely no solution. So this gives us no solution. And we will notice it when we have a multiple for the x value, the same multiple for the y value, and a different constant value over on the other side of the equal sign. This up here gives us infinite solutions. And we'll notice it when our x value is a multiple of itself, our y value is the same multiple of itself, and our constant is the same multiple of itself. Anything else is going to give you one solution. So let's apply that. Number 16, let's first check, make sure we are in standard form. And I see that I have ax plus by equals c. But here I have by plus ax. It's not in standard form, so I want to make it in standard form. I'm going to switch the order of these two values. So positive 4x and negative 8y equals 14. All right. Well, I can see that my x value, negative 1 times negative 4 is going to give me 4. 2 times negative 4 is going to give me negative 8. But 14 times negative 4 is not going to give me 14. So since my x and y both checked with the same multiple, I know I am going to end up with two lines that have the same slope. But since my constant on this side of the equal sign did not end up with the same multiple, I'm going to end up with a different y-intercept. So these will be two parallel lines and no solution. Number 17. Number 17 is often easier to see when we clear the fraction. So let's get rid of that fraction. In order to get rid of a 1/3 fraction, I'm going to multiply by 3. 3 times 1/3 is 1, so that leaves me x by itself. 3 times 15 is 45, which gives me that. And 3 times 4 is 12. That's at least now in ax plus by equals c, standard form. My second equation is not quite in standard form. I have ax plus by minus c is equal to 0. So I need to get the c over to the other side of the equation. I'm going to add 12 to both sides. So ax would be 1x plus b equals 12c. Now I can see my x's are the same, my y's are the same, my c's are the same. Well, that means I'm going to have two lines that overlap each other. Infinite solutions. You can certainly rewrite any equation into slope-intercept form. Slope-intercept form is probably the easiest way to recognize whether or not two equations have the same slope and whether or not they have the same or different y-intercepts. However, remember, it's going to take quite a few extra steps to change a problem that's close to standard form into slope-intercept form. So if you can remember these couple of shortcuts, it will save you some time when you're taking your tests. Number 18. Again, I'm going to clear the fractions because it's going to make it easier for me to compare the two equations. I have a 3 in the denominator, so I'm going to multiply by 3. 1/3 times 3 gives me x minus 2/3 times 3. The 3's will simplify out, so that leaves me with 2y equals 3 times 1, which is 3. Now I want to look for a factor. 1 times 3 gives me 3. Negative 2 times 3 gives me negative 6. 3 times 3 gives me 9, not 6. So since I ended up with a different value here, I know right away that I'm going to end up with two parallel lines. And two parallel lines will have no solution. Number 19. X equals 5, y equals 4. Now we should be thinking in our head, y equals this and x equals this, our little cheer that we've been doing in class, where y equals this, we put our hands out to the side, forms a horizontal line. X equals this, we put our hands vertical, it gives us a vertical line. Anytime I have a horizontal and a vertical line on the same coordinate plane, they will intersect. Not only will they intersect, but they're going to intersect perpendicularly, forming right angles. So that will definitely be one solution. Alright, our next equation is not in standard form. This one I would probably go ahead and write in slope-intercept form. Divide by 5 on both sides, and y is equal to negative 1/5 x. For my equation up top, if I subtract 4 from both sides, I'm left with y is equal to x minus 4. Like I was telling you earlier, you can very clearly tell that these two have different slopes. Any equations that have different slopes will intersect. But you can also see they have different y-intercepts. X minus 4 has a y-intercept of negative 4. This other one has no intercept listed, which means it's plus 0. So it's going through the origin. It has direct variation. So these would be one solution. 21. Y equals x and x equals y. For whatever reason, this problem tends to trick students up, and I'm not quite sure why. Because if x equals y, it's also true then that y is equal to x. So we're left with the equation y equals x and y equals x, and those are obviously the same solution, or same equation. So there will be an infinite number of solutions.